All right, well, this is Chapter 6, Section 6, Function Operations. Our learning objectives are to add, subtract, multiply, and divide functions, and to find the composite of two functions. So our essential understanding is you can add, subtract, multiply, and divide functions based on how you perform these operations for real numbers. One difference, however, is that you must consider the domain of each function. So when I'm adding two functions together, we write it as f plus g of x. So it's two functions, f and g, with the variable x. It's equal to f of x plus g of x. When we write f minus g of x, so we take function f, minus it from function g, both of them have variable x. It is f of x minus g of x. Multiplication, so when we write it like this, f times g of x, we really mean f of x times g of x, the two functions multiplied together. And then we write in function notation f divided by g of x, that is equal to f of x over g of x, as long as g of x does not equal 1. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. Also, the domain of the quotient function does not contain any value for which g of x is equal to 0, because we cannot have our denominators equaling 0. All right, so let's take a look at two functions. F of x equals 2x squared plus 8, and g of x equals x minus 3. What are f plus g and f minus g, and what are their domains? So the first thing we're going to do is we're going to take these two functions, f plus g of x is equal to f of x plus g of x. We're going to take f of x is 2x squared plus 8 plus g of x, which is x minus 3. And then I'm going to combine like terms if I can. I just have one squared term, so it's 2x squared. And it's just the x has itself no like terms, and 8 minus 3 is 5. Yay! So now that takes care of that. Boop. F minus g of x is f of x minus g of x. So f of x is 2x squared plus 8, and because I have a minus, I'm going to put all of g of x in parentheses. X minus 3. Then I'm going to distribute out the negative to these values here. So 2x squared plus 8 minus x plus 3. So I again have my 2x squared, so minus g of x equals, and then I have my minus x, because x doesn't have a like term, and then 8 plus 3 is 11. So the domain for both of these guys, there is no denominator restriction, neither on the composite nor the original, so we can say that the domain for both is all real numbers. Okay, so let's take the other scenario where we have f of x and g of x. So we're going to be multiplying and dividing those. So if I were to take f times g, that's my f function, 3x squared minus 11x minus 4. And timesing it by my g of x function, 3x plus 1. So when I do that, I have to FOIL. Everything here gets multiplied by 3x. So that's 9x to the third minus 33x squared minus 12x. And then everything gets multiplied by 1. So that's plus 3x squared minus 11x minus 4. Okay, combine like terms. F times g equals, do I have any other cubes? Nope, so it's 9x to the third. Check. Negative 33x squared plus 3x is negative 30x squared. I'm going to put a dot so I can remember I took care of that. Negative 12x minus 11x is negative 23x. Check, and then minus 4. All right, so now we're going to go f over g. So that's my f function over my g function. And I'm just going to make sure real quick that this doesn't factor. So I'm going to go ahead and try and factor this guy here. I'm going to test 3x plus 1 because it's my denominator. And 3x times x is 3x squared and 1 minus 4. So I'm just doing a little test. I don't yet know if this is going to work. 3x times x is 3x squared. 3x times negative 4 is negative 12x. X times 1 is x, and 1 times negative 4 is negative 4. 3x squared minus 11x minus 4. So this is true. So if I were to simplify this down, f over g, this 3x plus 1 over 3x plus 1 reduces to x minus 4. But I can't have 3x plus 1 equaling 0, because if it did, my denominator before I simplified would be 0, and that's not allowed. So let's go ahead and solve that out. 3x equals negative 1, and x cannot equal negative 1/3. So my domain is all real numbers except x equals 1/3. Sorry, negative 1/3. So even if your composite simplifies down to x minus 4, you still have to state that, okay, so we're all real numbers except x equals negative 1/3. Let me write that negative a little bit better. Negative 1/3. Okay, so when you combine two functions, you form what is called a composite function. So let's see how composite functions look. So if you look, it almost looks like a multiply sign, but it's not multiply sign. It means of. Multiply sign is filled in, and this guy is an open circle. So when this is g of x, g of f of x, so that means your first function is f of x, and you're going to input it into your g of x. So you can either write it as g with a little 0 of f of x, or you can write it like this with the parentheses, g of f of x. Okay, so let's see, given a function, so if I have f of g of negative 3, and f of x is x minus 5, and g of x is x squared. Let's go ahead. I'm going to rewrite this as parentheses, f of g of negative 3. So what I do is I'm going to go inside out. I'm going to find g of negative 3. So when I put negative 3 into my g function, I get out 9. So I'm going to find f of 9 because g of negative 3 is equal to 9. So then I take my f function, x minus 5, and I'm going to replace x with 9. 9 minus 5 is 4. So f of g of negative 3 is 4. Okay, so let's take a moment and see how this can apply to a word problem. So a store is offering a 15% discount on all items. Also, employees get a 20% discount. Write a composite function. So the first thing we do is we write store is 15% discount. That is, so we're going to let d of x be the cost after applying a 15% discount. So if I were to take away 15%, I would be left with 85%. So that's 0.85, the original cost. And the employee discount is 20%. So after I take off the 20%, I am left with 80%, which is 0.80 times the cost. So my first function, my 15% discount, is 0.85x. And then my 20% discount, my employee discount, is 0.80x. So what do we have when we go? Our first discount, then our second discount. So we have we do the store discount first and then the employee discount. So employee discount is on the outside, d of x is on the inside. So we go take the employee discount, which is 80%, and instead of putting x, we're going to put our d of x function. So that's 0.85x. So I'm just putting in 0.85x instead of x. So where the x happens, I'm putting parentheses, and then I'm going to insert into those parentheses 0.85x. So 0.8 times 0.85. Let's get out our calculator. 0.8 times 0.85 is 0.68. X. So our first discount, E of d of x, is equal to 0.68. So now I'm going to reverse that, and I'm going to take the 20% discount first and then the 15%. So I'm going to have d of E of x. So I'm going to take my d function, 0.85x, where I have x, I'm going to put parentheses. Inside those parentheses, I'm going to put my e function, which is 0.80x. And then I'm going to do the multiplication here, 0.85 times 0.8. And I get 0.68. So d of E of x equals 0.68x. So if you were an employee, which discount would you take first and why? The total discounts are the same, so it doesn't matter which one you would take first. you get 68% off of both, in both ways. All right, take a moment and summarize everything that we talked about. Make sure you put in there composite functions, how this little circle here doesn't mean multiply, but it means to put a function into another function. Make sure to include how to add and subtract, multiply and divide, and exclude any values that make the denominator equal to 0 before you simplify. Also put in there a composite function is two functions put together, and that you can combine functions as long as you keep track of the domain. And that's it. Thank you.